So previously, we talked about how to find the distance between a plane and a point in space. Now, this particular problem that we are looking at, we want to find the distance between two parallel planes. And you can turn this problem into finding the distance between a plane and a point if I just find a point in one of the planes. So how do I do that? Suppose my first plane is 2x. Let's make this minus 3y plus z equal 4. And let's our second plane to be 4x minus 6y plus 2z equal 3. Now, I want to find a convenient point located on this plane. So I'm going to say let y and z equal 0. If y is 0 and z is 0, then I have 2x equals 4 and x equals 2. Well, this follows that the point 2, 0, 0 is on the plane. So I do have a point on this plane. Now notice that this problem is just like previously. I have a plane, I have a point outside of that plane, and I can go ahead and find out the distance. So let's see, let me say that this is going to be my A, this is going to be my B, and this is going to be my C, and since 3 is on the right-hand side, it's going to be minus D. Let me go ahead and go to the next page. We know that distance equals the absolute value of ax1 plus by1 plus z1 plus d all over magnitude of the vector that I get from the second plane. So that would, let me write a squared plus b squared plus c squared. Okay. So d equals a is 4 times 2 minus 6 times 0 plus 2 times 0 minus 3 all over 4 squared plus minus 6 squared plus 2 squared. And d equals, I got absolute value of 8 minus 3 over square root of 16, 36, 4, so 56. And that is going to give me 5 over 2 square root of 14. Or you can think of this as 5 root 14 over 28 by rationalizing the denominators. The denominator. Okay, so let's do another one. Suppose this time I have my first plane is 6z equal 4y minus 2x. And 9z, my second plane is 9z equal 1 minus 3x plus 6y. So I'm trying to find the distance between these two parallel planes. The problem is telling us that these planes are parallel. So if I find a point in one of them, I can use my formula, anything. So this would be the easier one. If I let x and y equal 0, then I'm going to have 6z equals 0, so z equals 0. This follows that this plane point, the point, I should say 0.000 is on the plane. Well, that was easy. So now I'm going to go ahead and rearrange my second plane. I'm going to rewrite this as 3x minus 6y plus 9z, bringing him to the left-hand side. And this time I can say -1 equals 0. So this means that this is my A, this is my B, this is my C. And since -1 is on the right-hand side, that's going to be D. So D equals absolute value of AX1 plus BY1 plus CZ1 minus plus D over A squared plus B squared plus C squared. So let's continue on the next page. So D equals absolute value of 3 times 0 minus 6 times 0 plus 9 times 0 plus a 1 over 3 squared plus minus 6 squared plus 9 squared. So let's see, on the top I have 1, on the denominator I have square root of 126. So which is the same as saying 1 over 3 root 14. Okay, I can rationalize the denominator. This would be multiply top and bottom by root 14. So I'm going to have root 14 and the numerator. Then 3 times 14 is going to be 42. Okay, talk to you soon.